So conservation of mass is an important law. Matter is neither created nor destroyed in a chemical reaction. And this was something that Lavoisier was the first to demonstrate. Now, there are occurrences where significant changes in mass can occur, but these are nuclear reactions. They are not chemical reactions. So we will talk about nuclear reactions separately, but most of the course we're not talking about nuclear reactions. Any changes in mass are so minute in a regular chemical reaction that they're very, very difficult to measure, and so we can ignore them. The total amount of matter during a physical change or a chemical change stays the same. That's an important idea. Here's an example. Suppose we burn 58 grams of butane in a lighter. It will react with 208 grams of oxygen, and it will form 176 grams of carbon dioxide and 90 grams of water. So we could write all that information out this way. We're starting out with butane and oxygen, 58 grams and 208 grams. The total mass that we're starting with is 266 grams. Through the process of combustion, these are converted into carbon dioxide and water. Those are the masses of the individual substances produced, but the total mass is equal to the mass that we started with. So when you have a chemical or physical change occurring, the amount of matter doesn't change. So we sometimes throw conservation of mass problems into worksheets or exams, and what messes students up is they try to make it more difficult than it is. Okay, some of you have taken chemistry before, you know what stoichiometry is, and you know how to do all sorts of fancy calculations. This doesn't involve any of that. Suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide and how many grams of water? All this involves is a little bit of adding and subtracting. So what do we have happening here? We have natural gas and we have oxygen. So we've got gas plus oxygen. They're combining in the flame and they are making carbon dioxide and water. That's what the words are telling us. Carbon dioxide. Ran out of space. Plus water. So we're given masses here. 12 grams of natural gas. So there's 12 grams of gas and 48 grams of oxygen. And it produces 33 grams of carbon dioxide. And we want to know how many grams of water. So the total mass that you start with must be equal to the total mass that you end up with, right? Which is these two here. So we've got 12 plus 48, 60. So we got 60 grams here, and that must equal the 33 grams plus the grams of water. Let's call it X.
33 subtract 60X.
Yeah. Yep. So you just take the 60, subtract 33, and X equals 27. So we've got 27 grams of water. The idea is very important. The mass that you start with is the mass you end up with. Matter is not created or destroyed in a chemical reaction. Any questions?